A call from my friend. I wonder what it could be about. Hello? A math problem. Alright, try to explain it to me. That sounds really complicated. Why don't you just send it to me and maybe we can work this out together. Alright, group 4. Using the quadratic function, f of x equals x squared plus 10x plus 22, the point 1, 1, answer the following. Question 1. Write a function and model the distance between any point on f of x and the point 1, 1 in terms of the coordinate of the point on f of x. Question 2. What point on f of x is closest to the point 1, 1 and what is that distance? Question 3. What are the x coordinates of the 2 points on f of x that are 15 units away from the point? Okay, so first our question is write a function to model the distance between any point on f of x and the point 1, 1 in terms of the x coordinate of the point on f of x.
Variables. For our question, we need to understand our variables. X is our independent variable. It stands for the points on our function. Y is going to be the dependent variable and will eventually stand for our distance between the point on our function and the point 1, 1.
So first we're going to simplify our quadratic. This makes our formula easier to use. So our quadratic is y equals x squared plus 10x plus 22. So first we're going to complete the square. So our first step is going to be add 3 on both sides, so that way we can get a perfect square trinomial. Next we're going to put the 3 from the other side and we're going to bring it over. And then we're going to condense our formula so that we have our perfect square trinomial. And we're going to condense it one more. So we have y equals x plus 5 squared minus 3. And that's our answer. So that's a simplified quadratic that we can use in our equation. Alright, so next we're going to use the distance formula. The formula will help us answer question 1, which asks us to model the distance between any point on our formula and the point 1, 1. So first we're going to use the distance formula. Of course, square root of x1 minus x2 squared plus y1 minus y2 squared. We're going to replace x1 and y1 with 0.11 because that's the points we were given from the function. Next we're going to replace x2 with x because we're plugging in our x, and that will be x2. Replace y2 with our function x plus 5 squared minus 3 because y equals x plus 5 squared minus 3. Alright, so let's clean this up a little bit because we have kind of a messy thing. So first thing we're going to do is distribute our negative. Alright, so now that our negative is distributed, we can combine like terms. Alright, so now we end up with a function that has as simple as it can get. And so our function is y minus x quantity squared plus 4 minus x plus 5 quantity squared, and that's good. We're going to take the square root of that function. Alright, so now we have our answer to question 1, which is this distance formula, square root of 1 minus x squared plus 4 minus x plus 5 quantity squared squared. Alright, so question 2. What point on f of x is closest to the point 1, 1, and what is that distance? Alright, so now it's time to use our calculator. So first we're going to hit the y equals button on our calculator, and then we're going to type in our formula to y1, root of x minus 1 squared plus 4 minus x minus 5 squared, quantity squared. So next we're going to hit the graph button, and wait for it to load. And since we can see the mem, we don't currently need to adjust our window. So next we're going to hit the second trace / calc button, then the number 3, and we're going to choose a point left of the visible minimum, and we're going to choose a point right of the visible minimum, and we're going to choose a point in the middle. The minimum that appears at the bottom is 2.890905.1, 1.9433163. The distance is equal to the y, therefore the shortest distance between the two functions is 1.9433163. Question 3. What are the x-coordinates of the 2 points of f of x that are 15 units away from that point? Alright, so we gotta hit the y equals button, and then we put on our line y2, 15. And so next we gotta adjust our window, so it's 20, so we can see where f of x intersects y equals 15. Then we're gonna find the intersection points by intersecting calc, and then hitting the 5 key for intersect. Then we're gonna hit a point on our left side of our f of x function, or the left side of the y equals 15 function, and choose a point close to where they intersect. And we got our first intersection point. We're going to do the same thing. We're going to hit second calc, 5, and we're going to go to the right half of the function. So we choose a point on f of x, we choose a point on y equals 15, choose a point close to where they intersect, and we get our second intersection point. So the answers we get are 0.6415922, 15, and 9.079020815. So those are our 2 points where f of x equals 15. Alright, so we finished. So for question 1, write a function to model the distance between any point on f of x and the point 1, 1 in terms of the x-coordinate of the point on f of x. We got root of 1 minus x squared plus 4 minus x squared plus 5 squared quantity squared. For question 2, what point on f of x is closest to the point 1, 1, and what is that distance? We got the point 2.890905.1, 1.9433163. So that means that our y distance and our distance apart is 1.9433163 units. For question 3, what are the x-coordinates of the 2 points on f of x that are 15 units away from the point? Our answer is 0.6415922, 15, and 9.079028015. Alright, I'm glad I could help, man. So if you need any other questions about math, just give me a shout.